This is Fun with Electronics Project 3, Part 3, where we combine Circuit 1 and Circuit 2 and see their behavior. See how they both behave at the same time when they reach certain water levels. So I initially was gonna go for this circuit and tested it, but it turned out to be a failure due to several reasons. Maybe my best guess is that the water's resistance was probably too high, or maybe the transistors for on circuit 1 pulled like more of the current, leaving circuit leaving the high and low level wires with almost no voltage. So yeah, so after days of troubleshooting and circuit testing and desk wetting, you could check that out on the bloopers if there's gonna be. So so at the end, the circuit was built. Let me just zoom out real quick. So here we have 3 stages, 3 levels, and I'm using 12. I'm gonna use 12 volts, and that's the first circuit. Here's a source, the high level probe, the middle level probe, and the low level probe or wire. Um, the reason I decreased the number of levels is to prevent any loss in voltage for circuit 2. And one of the changes I made was adding a voltage divider right here because in one of the failed experiments that I did, I found out that the water was grabbing most of the current, most of the voltage. So the plan was to decrease the threshold and the trigger of the 555 timer so that its boundaries could decrease from 12 volts to 6 volts. Since the voltage that the low level and high level probes are receiving are around 5 volts, 4 volts, which is actually less than the threshold voltage, basically, and which was part of the problem. So that's why this voltage divider is right here, to decrease that boundary, basically, so that it could accept the voltage of the value of 5, close to that, actually. So, but most of the circuit, as you can see here, is the same as the old one, as the old version, which is connected to the second part, which is a relay transistor, which is an NPN 2N3904 to be specific. And these two resistors, I believe they're 1 kilo ohm resistors. Yes, they are. All right, and then I didn't have any space to make it bigger, but here I think it's connected to the normally open contact. So it's connected to an LED and the buzzer, which is supposed to be the pump controller. But since we don't have that, we're replacing it with an LED and a buzzer to indicate its state, whether it's on or off. So yeah, like I said, troubleshooting was really, really, really painful. It took me about like 3 days to find the cause of its failure, and yeah. So here's the hardware. Here we have circuit 2 on top, and here we have circuit 1. And the LEDs that we're going to be looking at are the white, green, and red LEDs. And here we have the buzzer connected to the red LED. All right. So let's turn it on.